Okay, welcome to another video of computational thinking and algorithm unit of IGCSE. In this unit, we are going to talk about defensiveness and data validation. Okay, so before we studied about the control structures, and one of the uses or one of the places that you can use control structures is in defensiveness and data validation. Simply, this unit is about making sure that the data user enters is correct and acceptable. Okay, so we will be just discussing about that. So first of all, okay, defensive programming. What is programming? Defensive programming is the practice of anticipating user behavior and handling unexpected input without the program crashing. So here simply we will consider or we will assume that user might enter wrong input. Okay, and we have to just think about this. What type of wrong data user can input, and we have to handle that in our program. Okay, robustness of a program simply it means the ability of a program to accept, process, and respond appropriately to user input, even when that input is completely erroneous. For example, you need a number, user enters some letters, or for example, the data range that you are accepting is between 1 and 50 and user enters 55. Okay, or somewhere that you need data and data must be entered, user just does not enter anything. Okay, so they are erroneous data, and we will just simply code in a way that our program should be able to respond correctly and appropriately even with the wrong inputs. Okay, and a pro tip here is just a robust program never assumes the user will type what they are supposed to. So always they will just consider that user will input wrong data here. Okay, so that is what they will assume. Now the filter, okay, or data validation. Okay, data validation is an automatic computer check to ensure data entered is sensible and reasonable before it is processed. For example, you are creating a software for a football team that accepts people between age 18 and 35, and user enters 40 or 45, so that is unacceptable. You have to just kind of filter that. Okay, so that is data validation. If user enters any number outside the acceptable range, your program should just simply give them a message and maybe just take the input again. Okay, or for example, number is needed and text is entered. Okay, so your program should be able to just simply tell the user that we accept only numbers here, and retake the input from him. Okay, or the patterns, it is email, so inside email it has to check there has to be one at sign and one dot. Okay, and exactly one of them. So that is as kind of data validation. There is a golden rule, okay, that you have to understand about validation is validation checks rules. It cannot check correctness. For example, your rule is age should be between 18 up to 35. Now your program will check the data if it is inside this range. That is the rule. Okay, but maybe just the age of user is 25 and he has entered there 23. Validation cannot check that, cannot check correctness. Okay, so validation ensures an age input is, for example, between 0 and 120 sensible. Okay, that can be just age of person, but age cannot be negative and cannot be just higher than 120. So it cannot prove that the user is actually 15 instead of 16. Okay, so validation checks rules but it cannot check correctness. So that is data validation. So the validation metrics, the first one is length check. Okay, and the types of validation or the types of check that we want to or we might need to have in validation. Okay, the first one is length check. For example, in many places you might have seen that the password must be at least 8 characters. So when you enter a password there, the system checks if that is 8 characters. If that is 7 characters, 6 characters, then it will simply give you a message, an error message, and it will tell you to re-enter the password. Okay, so that is length check. check if input has a specific number of characters. The next one is range check. So the examples that we told you, okay, the age must be between 0 and 120. Or for example, score cannot be lower than 0 and higher than 100. Okay, so that is range check. Mistakenly, user should not enter any number that is outside the acceptable range. Okay, so range check ensures numeric or alphabetical input falls within a designated boundary. Then presence check ensures a field can not be left blank. You need a data somewhere, okay, and user just simply does not fill that. For example, name, and you said that yeah, name is a must data and it should be there. Okay, so simply checking if a user has entered any data somewhere, that is presence check. Okay, and pattern or format check ensures data matches a specific template. For example, for email, as we told you, must have an at sign and one dot, okay, and exactly one at sign, not more than that. Okay, so that is this kind of pattern check. Or the other example here, we have gotten car registration format, that is XX99XXX. Okay, it means 2 letters, then 2 numbers, then 3 letters. If user enters a data like 1234CCC, this has to just fail because yeah, the first 2 letters, the first 2 characters must be letters. Okay, so this is an erroneous data and it should not be accepted. So that is length check, range check, presence check, and pattern or format check. And type checking and explicit coercion. Okay, that is very important. For example, that is a number and you need to perform some calculations on that letter, so you have to change it to integer or to just float, okay, or to real. So type checking prevents fatal crashes caused by mismatched data types in the future. Okay, so when the data is entered and you know that, for example, I need this in this format or in this data type, you have to just explicitly cast or change the data type of that. Okay, so in pseudocode we do it this way, saying please enter your age to display and receive age from keyboard, and before keyboard here we have just written integer. It means just whatever user entered, input is mainly or just originally input is a string, so you are just telling it to change it to integer and store it inside age. Now after this we can perform mathematical operations on them. Okay, so the integer command forces one explicit coercion. Okay, it assumes and converts the keyboard input directly into an integer data type. Then also there is another thing. Okay, while changing this you have to use error handling techniques like try and except for runtime errors. Okay, here if user enters Ali or just any letter, that cannot be changed to integer, so your program will just give you an error. Okay, now in Python or just in coding you have to just be careful about that. Then using explicit coercion guarantees the variable is treated as an integer immediately, preventing logic errors like accidental string concatenation later in the program. Okay, so if you just do not do that later in the program, your program will just behave like a string with that data. Okay, and here is the sensibility versus truth balance. As we told you, data validation cannot check the truth, okay, or just correctness. So that is validation, that is the automated robot mechanism. Automated sensibility checks against programmed rules. You will just program them. Okay, and scope catches data that is impossible or highly unlikely. And limitation is it cannot know if the data is a lie or a truth. Okay, so that is. Then verification is the source truth. Here we will just simply check that yeah, is this user telling the truth or not. Okay, and that mechanism mechanism for that is checking data against a source document or user confirmation for absolute correctness. For example, your password. Okay, so your password is stored in a database, and when you just enter your password to any system, your password will be checked with the main password. Okay, so that is verification, checking if it is true. Or double entry, forcing the user to type an email twice to catch typos. Okay, so they are just verification, validation and verification. Validation is just simply checking the data against some rules, and verification is just comparing that with the source truth to say if it is a lie or a truth. Now, how do we implement the validation? Okay, that is very simple. We just loop until data is valid. See, input data, check if data is valid. If it is not valid, output an error message, then input data again. And this loop continues happening, okay, till data is valid. Well, when data is valid, then after that, yeah, you will process. Okay, receive data from keyboard. While data is invalid, do this. Okay, send error message. It can be just any kind of error message based on the type of error you are checking for. Okay, and then after that, receive data from keyboard again and end while. Okay, so that is just simply how we implement validation. Okay, we loop until data is valid. And proving the filter, okay, testing validation. Uh, we want to test our program, okay, whether just does it work really well now or not. We have just created our program and we want to check does it really work well with the correct and incorrect data. Okay, so erroneous data. Okay, erroneous data is a data that breaks the validation rules and should be automatically rejected. For example, see here, if we are just accepting number between 1 and 50. Okay, so we have gotten three types. We will just simply use sample data. Sample data is just the data used for testing. So we have gotten three groups of sample data, or three types of sample data. The first one is normal data. Okay, normal data is just acceptable data that your computer should just work with them normally. Okay, so for example, here the number 25. So normal data tests standard operations deep inside the accepted logic. Okay, then we have got an extreme or boundary data. Here that will be 1 and 50. Okay, test the very edge of the accepted logic. So does it work well with 50? Does it work well with 1? Okay, so that is boundary data. And erroneous data, that is just data which is not acceptable. For example, 0 should not be accepted here. Okay, and it should be rejected, and user should be asked to enter the data again. Okay, and 51 or just numbers higher than that, or any text, for example. Okay, so that is test the very edge of the rejected logic, that is 0 and 51. And just erroneous data tests wrong input. Okay, and checks if our program works well with that. Then the robust input lifecycle. See, we just talked about robust data. Okay, robust programming. Robust programming simply is the one that handles the wrong inputs. So see, coercion. Enforce clean typing using explicit typecasting upon reception. Okay, so when data is entered, change it to any data type that you just need. Okay, then after that, validation. Check for the rules. Okay, things like range, length, format, or pattern that we discussed about. Then after the trapping, isolate execution inside condition loops if failure occurs. So we just had a loop. Yeah, if just data is erroneous and not acceptable, then simply it loops there. Okay, and processing. Okay, and then after that, if data is just completely right, then process the program. Okay, or process the data. That is just the robust input lifecycle. Some exam insights or exam tips. Okay, again, terminology precision in your answers. Okay, do not be vague. Okay, for example, filter software, use things like length check or presence check. Okay, so you have to use the technical terms for that, for your answers. The UX mandate. Okay, a robust program doesn't just crash or infinitely loop in silence always. Okay, so that will simply output an error message to the to guide the user to correct their mistakes. Okay, so that is robust program. Okay, it does not crash or loop infinitely. Then erroneous selection rules. Okay, when asked to provide erroneous test data for a specific rule, pick data that fails only that specific test in your exam. Okay, so they will just simply tell you for this test, give us some examples for erroneous data. Okay, so you have to write data that specifically fails only that rule, not some other rules as well. Okay, for example, if testing a 7 character length rule, AB12CD is perfect. Okay, this only fails length, but 1 2 3 4 CCC is poor because it fails length and format rules. Okay, so it fails both of them, so that is just not correct. Although, yeah, this is just an example. uh, Remove 1C, okay, because this will not fail the length rule. So that is just kind of it. And practice on some questions, think about them. Okay, uh, define data validation and state its golden rule. Think about that. What was the answer? Question number 2, an algorithm accepts. Question number 2, an algorithm accepts ages 12 to 100. Provide the 3 specific pairs of test data required for comprehensive boundary testing. Pair 1, lower boundary; 2, upper boundary; and pair 3, erroneous data. Okay, so you can just give us some examples there. Now for this first one, okay, we can, sorry. Now for this lower boundary, mainly we just use the lowest acceptable number. Okay, but because here it has asked as pair, so we will just give the lowest acceptable and the highest unacceptable. Okay, so between them it means 2. For example, 12, so that will be 11 and 12. Okay, so 11 is erroneous data, but again that is in boundary. Okay, mainly it comes in erroneous. Then upper boundary, 100 and 101. Okay, 101 commonly just comes to erroneous data, but because here we have just it is asked pair, so pair, that will be just kind of, we will check both of them. Okay, but if only one is asked, give the lowest and highest acceptable data. Okay, then write EDXL pseudocode for a system that asks for a new password. It must use a while loop to continuously reject the input and output an error until the password is greater than 8 characters. So that's it. Wish you all the best. Okay, keep practicing, keep learning, and keep shining. And do not forget to like and subscribe our channel.